Before we begin, let me ask you one thing. What happens when Europe's chip strategy collides with geopolitics? Supply chains start to reroute themselves, and the world's most advanced chipmaker shifts even more production to the US. Because that all happened in 1 week. And the ripple effects could reshape who controls the global AI hardware race. If you want to understand where chips, AI, and global power are heading, this is the episode you don't want to skip. Hello and welcome back to Chips Weekly by Diana. I'm Diana, and this week delivered a powerful mix of political urgency, supply chain disruption, and strategic expansion that tells us exactly where the semiconductor world is heading next. Here's what we're unpacking today. Europe is pushing hard for more pragmatic and execution-focused Chips Act 2.0, warning that without a faster decisions, the continent will fall apart even further behind the US and China. Nexperia, once again caught between Europe and China, has begun rerouting its supply chains in real time to keep European factories supplied. And TSMC CEO announced plans to deepen the company's US footprint to support explosive AI demand, a move with massive strategic implications. And in our industry spotlight, we'll examine the hidden crunch behind the AI boom, why memory, networking, packaging, and analog chips, not GPUs, may become the big next bottleneck. And we'll close as usual with the chip of the week. So let's get started. Story number 1. Europe calls for a more pragmatic Chips Act 2.0. This week, Europe's semiconductor industry escalated its calls for a far more practical, fast-moving and coordinated version of EU Chips Act. The issue isn't the ambition, it's execution. Industry leaders argue that Europe risks falling even further behind the US and China unless Brussels streamlines funding approvals, cuts the administrative delays, aligns member states, and supports the entire semiconductor ecosystem, not just wafer fabs. What does it mean in practice? Europe needs to accelerate investments in advanced packaging, materials, design, EDA, and, importantly, equipment. These are the missing pieces that still force Europe to rely heavily on foreign suppliers. The message delivered to Brussels this week was blunt. Europe won't reach semiconductor autonomy unless it stops thinking in terms of construction projects and starts thinking in terms of full industrial ecosystems. This shift from optimism to urgency marks one of the most important policy moments of the year. Story number 2. Nexperia Reroutes supply to avoid Europe-China fallout. Nexperia, a key player in Europe's mature node semiconductor supply, is now navigating a complex geopolitical storm. As scrutiny over its Chinese ownership intensifies, the company announced it would reroute chip shipments through alternative logistics paths to avoid disruptions for European customers. This includes redirecting packaging and test to non-Chinese facilities, leveraging partner foundries, and operating new regional distribution channels. Why it's such a big story? Because Nexperia produces the essential chips that Europe's industry run on. The power components, the logic devices, diodes, automotive-grade electronics, the everyday silicon that keeps factories moving. If Nexperia slows down, Europe's car makers, industrial firms, and energy systems will feel the impact immediately. For now, Nexperia's workaround is holding, but this week showed just how exposed Europe remains when political tension interacts with supply chains. One conflict, one export rule can ripple across the entire continent. And finally, story number 3. TSMC expands US manufacturing to meet AI demand. TSMC CEO made major headlines this week by announcing a deeper and a more aggressive expansion in the United States. Why now? Because AI demand is not just rising, it's accelerated faster than TSMC's original forecasts. The biggest AI chip designers, NVIDIA, AMD, Apple, Amazon, Google, and Microsoft, all want advanced manufacturing capacity closer to home. TSMC expanded US strategy includes more cutting-edge nodes built in America, more advanced packaging on US soil, tighter integration between the US design teams and US fabs, and long-term repositioning of the global AI supply chain. This marks a strategic rebalancing of global chip production. TSMC isn't just pulling away from Taiwan, but it's diversifying risk and capacity, and it signals something deeper. The center of gravity for AI hardware is shifting, and TSMC identifies the core of it. Industry spotlight. The AI manufacturing crunch nobody is talking about. Let's step back from the headlines. While GPUs dominate the conversation, there is a quieter and more dangerous bottleneck building beneath the surface. AI is training the entire semiconductor ecosystem, especially memory, networking, packaging, and analog components. Every new AI system requires more bandwidth, more power delivery, more terminal capacity, more optical networking, and more chiplet packaging. And of course, far more advanced interconnects. And right now, the supporting components simply can't keep up. HBM supplies are tight. Optical transceivers are seeing steep lead time increase. Power management chips are running hot in demand, and advanced packaging is already booked out well into 2026. This explains why TSMC is in the US. Europe is pushing for more practical Chips Act, and companies like Nexperia are scrambling to stabilize supply. Because the next era of AI wouldn't be limited to the GPUs. It will be limited by everything that surrounds them. The regions that control those supporting components, memory, networking, packaging, and materials, they will define the future of AI power. Finally, the chip of the week. So for this week's chip of the week, we spotlight a major milestone in chip technology. TSMC's first ever silicon on its 1.4 nanometer A14 node. This is a successor to N2P. The early results are impressive. A14 uses second generation gate-all-around nanosheet transistors, offering tighter control over current and improved switching behavior. It incorporates a more advanced backside power delivery system, reducing resistance and enabling higher performance headroom. And the gains are real. TSMC reports 12 to 15% better performance per watt compared to N2P, before partners even begin optimizing their architectures. But beyond the engineering, A14 sends a message. TSMC identifies to remain a process technology leader at a time when Intel, Samsung, and China's domestic players are all pushing the breakthroughs. This chip is not just a shrink, it's a marker for a next generation of AI, mobile processors, servers, and chiplet-based systems. The race continues, and A14 puts TSMC one step ahead. And that wraps up this week's Chips Weekly by Diana. If you enjoyed this episode, hit like, subscribe, and share it with your network. And tell me in the comments, which part of AI supply chain do you think becomes the next big bottleneck? Until next time, stay curious, stay sharp, and as always, stay chip aware.